Okay, are we ready? Okay, everybody say hi. Oh, who did I just say? Emma, Kelsey, Marcus.
Marcus is stupid.
Okay, they don't want to say hi to you. All right. So yesterday we started filling out the top part of this paper. Multiplying was on the top. We had independent versus dependent events. The key word there was and. That's when you use multiplying.
This one is
okay?
or.
And multiplying. You are doing two or more events for any scenario. If I'm drawing two cards, if I'm selecting two people, if I'm rolling two dice or three dice or four dice, right? That means I'm going to be multiplying. When you are adding, you are only doing one event. So you're only picking one, I'll say thing, like one card or one dice or one person, okay? So examples for this look something like this. Let's say, well, my scenario up here was the probability of drawing a king and then a 7. So I'm going to do probability of king or a 7. Okay? Now, if I'm doing king or a 7, how many cards am I actually drawing?
2. 1.
I'm only drawing one card. I want to know if that one card is a king or a 7. That's it. Okay? So, what I do here is I add them together. A king or a 7. What's the chances of getting a king?
4 out of 52.
4 out of 52. What's the chances of me getting a 7?
4 out of 52.
4 out of 52. Now, do not reduce. Well, I guess you can in this case. But do not reduce until after you add them together, because otherwise that will get rid of your common denominator. Okay, 4 out of 52, 4 out of 52, that would be 8 over 52, which is, now you can reduce, I guess. If I divide both of them by 4, that would be 2 over 13. So 2 out of 13 is my chances of getting a king or a 7. Okay? Good? Yeah?
Sure.
All right, next example. Also adding, but I want to know the probability of getting a king or a heart. I'm going to change it just ever so slightly. How many cards am I drawing?
1.
Still only one, right? Still only one card, and I want to know whether that card is a king or a heart. Except in this case, I'm going to do 2 little bubbles.
Hearts.
Okay? Kings versus hearts. Okay? There are 4 kings and there are 13 hearts. Is there a card that is both the king and a heart?
Yes.
It is the king of hearts, right? Okay? So that was a problem that we did not have on the left side. We did not have a scenario where we had a king and a 7 both at the same time, right? You can't have a king and a 7 at the same time. But you can have a king and a heart at the same time. So the chances of me getting a king is 4 out of 52. Okay, I'm going to still add that to the chances of me getting a heart, which is 13 out of 52. But the king of hearts, that one card, appears in this category and in this category. But the king of hearts is only one card.
Subtraction.
So I want to subtract 1 out of 52, because then he will only be counted in one area instead of 2. Does that make sense? Okay, we've kind of done this before, I think. Maybe. Okay. So 4 out of 52 plus 13 out of 52 minus 1. 4 plus 13 minus 1 is 16. Out of 52, I can still reduce and divide by 4. So this guy would be 4 over 13. Okay, so changes just a little bit. Does that make sense? Okay, so kind of like we had independent versus dependent. You guys know what these labels are?
No.
These ones are called, let's do over here. These are called exclusive. The word exclusive, you see the word exclude. Do you know what it means to exclude somebody?
Yeah.
You don't include them, okay? So if you exclude the 2 things, the king and the 7 are excluded because they have nothing to do with each other, right? King and 7 are two separate categories. Versus the right side example, what is he? You have exclusive and inclusive, okay? In the word inclusive, you see the word include, and that is because there is something included in both pieces, right? Okay? The king of hearts, the one card, is included in both categories, okay? What's the key word like we circled up here?
Or.
This one is or, okay? You know that you're only picking one thing if it's an or event, okay? I want to know, I have 2 categories still, a king and a 7, but I'm doing one or the other. I'm still only picking one card, but I want to know if that one card is from 2 categories, okay? So let's do exclusive versus inclusive. On your homework assignment, you could put E or I. On your homework assignment, they will ask for, don't write this down, they'll say mutually exclusive or not mutually exclusive. They'll say, tell me whether it's this or this. Okay, you don't have to put not mutually exclusive. Go ahead and put inclusive. Does that make sense? Because it's a lot faster to write inclusive versus not mutually exclusive. Okay, so scenarios. Junior and senior, exclusive or inclusive? Junior and senior. Exclusive. You can't be both at the same time. Volleyball and basketball. Can you have a person that plays volleyball and basketball? Yes, you can. That's inclusive, right? A lot of you guys are in that category. You play volleyball now and you will play basketball. What about, I don't know. What about wrestling and basketball?
No.
That's exclusive because we could not have that scenario. Does that make sense? What's that? Yeah, that's true. That's true. If we're talking about elementary, then it would be inclusive. Okay, so you guys get the idea. There's nobody in the bubble, or there is somebody in the bubble. Okay. All right. So let's go to your notes, which is 12:6, which is adding, probability, and the addition rule. These are mutually exclusive events. So there is nobody in the middle here. Okay. For exclusive events, there is nobody in the middle. Okay. All right. Determine whether the events are mutually exclusive or inclusive. So we're going to write E or I. A junior winning an election or a senior winning an election. Exclusive. A sophomore winning an election or a female winning an election. Can you be a sophomore and a female at the same time? You betcha. Drawing an ace or a club. Can you be an ace and a club at the same time? This one I have to kind of think about because ace is one of these, right? That's like the number one basically in cards. And a club is the flower.
Yes.
Okay.
I don't know cards.
These are clubs. We played I played cards with my friends a couple weekends ago, and we were playing pitch. I've never played pitch before, 10-point pitch, okay? So evidently you like pick what the suit that you're going in is, whatever. And they said, okay, trump is spades. And so I said, okay, great. So I put all the rest of my cards down and I pulled spades, and the person sitting next to me was like, I don't want to like say that I looked at your cards, but you have all clubs in your hands. Like, I picked the wrong card, so we had to like misdeal and whatever else. So the club is the flower, right?
Yes.
The spade is the shovel.
Yes.
Okay.
The shovel.
Can you be an ace and a club at the same time?
Yes.
Yes, so that is
The diamond.
inclusive.
A diamond's a diamond, a heart's a heart.
A spade's a shovel.
A spade's a spade.
A spade's a shovel and a club's a flower. Spade. This is a spade.
Why couldn't they just do a flower and call it?
That's a spade.
Yes, that's a spade.
Spade.
Say what you use in the garden.
A spade is what you use in the garden. Yep.
Okay.
It's an upside down
Shovel. I
heart.
choose shovel.
I choose shovel.
It's an upside down heart. There you go. Okay.
Can I open my water real quick?
Yeah.
No.
All right. Mutually exclusive events. Example 2. Ramiro makes a playlist that consists of songs from 3 different albums by his favorite artist. If he lets his MP3 player select songs from this list at random, what is the probability that the first song is played from album 1 or, there's that word, or album 2? How many songs is he actually choosing?
I have no clue.
One song. He's only choosing one song from album 1 or album 2. How many total songs are there?
35.
35. Okay. Album 1, what's the chances of him drawing from album 1? 10 out of 35. Okay, 35. Plus album 2 is 12 out of 35, which is a total of
22 over.
22 over 35. Will that reduce?
No.
I don't think so, actually. 22 out of 35. That's my probability. Make sense? Okay. Now, not mutually exclusive, or I call them inclusive. So if you want to do inclusive because it's a lot less to write, then not mutually exclusive, that's fine. Okay. All right, they give you this little table right here. Okay, these are paintings that this girl is doing. So she has 4 still life, which are like trees and stuff, probably, or apples. Like, you know, the pictures of the apples just sitting on the desk. That would be a still life. 4 of them that are watercolor. Oil painting, that's what I like to do because oil doesn't dry for like 2 weeks. And I can just sit and nitpick it to death. Oil painting, she has 3 of them that are a portrait, right? So these are the people's faces. Do you see how this table is red?
Sure.
Okay. All right. So how many total still life did she have? If you add all these together,
6. I mean,
9. 9 total. 9 total. Okay. How many portraits? 10. How many landscapes?
3, 4,
11.
5,
Okay.
6, 7.
How many total watercolor?
30.
What?
Oh,
Total
I
watercolor all the way across?
12.
That's
12.
There are in the total of all them.
How many total oil? Okay. All right. We'll ask you here in a second. 6. How many total acrylic?
6.
6. This
Six.
looks like 16, but it's not. Blah 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 blah. This thing going down here. And 6. And how many total? Gracie.
12 plus. How many that is?
Girl,
18.
you just had it.
12.
You just had it. You can either add 9, 10, 11,
30.
or you can add these 3 together, right? Or those 4 together. Yes. 30 total. So 30 going across, 30 going down. There's 30 paintings represented on this thing. Okay, so the table shows the number and type of paintings Namiko has created. If she randomly chooses a painting and submits it to an art contest, what is the probability that she selects a portrait or an oil painting? Okay, so I'm going to look over here. Portrait, oil painting.
3 out of
Okay,
30.
now how many portraits are there? 10. How many oil paintings are there?
Isn't it 13?
6.
6, yeah.
I'll do these. There are 10 of them.
And then 3
Okay.
in the middle.
Oil, there are 6 of them. And how many are both?
3.
3. That's this little guy where he overlaps,
So
right?
it's 10.
10
Okay.
plus 6 minus 3.
Hold on. 10 over
30.
30 plus
6 over 30.
6 over 30
Minus 3
minus
over
3 over 30 because those 3 are counted in both of the
13
loops.
over 30.
Do you guys see how this works? Those 3 right here are counted in both of the loops.
Yeah.
They're counted in this loop and in this loop, but I don't want to count them twice, right? Okay. So I have to subtract them out, and that is what? What'd you say? 13?
13.
Does that reduce?
No.
No.
Nope, because 13 is prime, and there you go. Okay? It might help to make a Venn diagram like this guy where they overlap. That might help each time, right?
Okay, what's the homework?
So I would encourage. Oh, is that it? What? Oh my gosh, that's crazy. That's crazy. Okay, so homework. I'm gonna put it at the top of here so that the people who are
Page
gone.
900.
No, I
Rachel,
don't.
can I have a paper?
Probability and addition rule. Page 900.
Thanks for meeting us. You're welcome.
8 through 28 evens. And 36 through 40 the evens.
Gross.
There you go.
Where's a book?
Okay, there we are. Holy cow, it's not even 8:30 yet. Bye, guys. Nobody else wants to say bye?
I said like,
Bye.
Goodbye.